What's up everyone, this is Dariusz Kalbarczyk, co-founder of MG Poland, JS Poland, Qwik Poland and WorkshopFest.dev. Welcome back to the JavaScript Master Podcast. Today, together with Miško Hevery, who is an CTO at Builder.io, creator of Qwik, Angular, Angular.js and co-creator of Karma.js, we will talk about QWIK Advantages. Hi Miško, how are you today?
Hi, how's it going? Thanks for having me. I'm awesome.
I am very glad to talk with you once again about QWIK. Let's start. Miško, can you tell us how the process of loading the page on production look like step by step and how it differs from development?
Yeah, so maybe we should start even higher and talk about how is it different from other frameworks. Okay, so let's back up a little bit. The way, if you're familiar with Vite, it is kind of becoming the de facto standard for new technologies, etc. Vite is awesome. What Vite does is it sends one file at a time. This is great for development mode. This is not what you want to do for production because that would cause waterfall effects, etc. But for development mode, it's actually a really, really good way to do it because it allows hot module reloading. You don't have to pay for the price of bundling, etc. So that's a good kind of a mental model to start. Now, what Vite does is really just serves files that you have on your disk to you, right, before bundling happens. And that means that Vite can't really just send you half of the file. It can only send you the whole file, right? So if you edit a particular file in your IDE, then Vite can send that new file to the client and just that file and nothing else. So QWIK comes in, and QWIK has this interesting thing called an optimizer. And what QWIK does, or the optimizer does, is that it looks for a function call that has a $sign at the end of its name, right? So it's intentionally generic because we want you as a developer to be able to create your kind of own functions this way. So we don't want to just special case certain functions. And we chose $sign because it's both silent, but it also communicates to the developer hey, something weird is about to happen over here. Some special magic is about to happen here. And so what the optimizer does is that every time it sees a $sign, a function call with a $sign, it takes the first argument of that function and moves the first argument into a separate file. Now, there's implications in it because what you have just done is you made things asynchronous, right? Because you have essentially what you left behind is a dynamic import. But let's kind of glance over that for a second and really just focus on the fact that what the optimizer does is that every time it sees a $sign, it breaks your file up into small, tiny chunks. And these are the chunks that we hand over to Vite, right? So in a development mode, what Vite downloads is essentially not files, which is what kind of you're used to, but instead it downloads these individual functions. I guess typically when you have a function with ends in a $sign, the first argument typically is a function. It doesn't always have to be, but let's kind of for simplicity, let's talk about it as a function, right? So instead of downloading the whole file as a unit, what the optimizer allows us to do is to download individual functions in the file. And this is kind of the big important kind of step because it kind of changes the way you think about loading your code. Instead of loading your code per file, in other words, as a developer, putting things into a same file has consequences because bundlers know how to put things together. They don't know how to separate things out. And so by putting things into a same file, you are limiting the choices for the bundler. And so what the optimizer does is it says, you know what, it's convenient to put things together in the same file, but actually we would prefer to think of it if things were broken up. And so optimizer goes and breaks this up, which means it doesn't matter how much stuff you put into a file. The optimizer basically says actually it's per function, right? So this is a function that you can download. This is another function that you can download, and so on and so forth. And so what happens is the beat then serves up the individual functions to it. No, they're served up as a file, right? So we create a kind of a bogus file for beat. But the way to think about it is you're serving up functions, not files. And that's kind of an interesting superpower, right? Because it now means that instead of downloading kind of large chunks that logically make sense to you as a developer, you are now sending much, much smaller pieces to the client. Now, in a development mode, what you actually will get to see is that, well, you kind of make the waterfall worse, because now, instead of waterfalling across files, which are relatively big units, now you're waterfalling across functions that are smaller units. And so inside a development world, like it may look like it's kind of a worse thing, but in development local burst, it doesn't really matter in that particular mode. But what that allows us to do is how things change in production. So in production, you take your files and you bundle them together into fewer files so that you improve the waterfall model, right? And we kind of already implied that the bundler doesn't know how to break files apart. Bundlers really only know how to put files together to kind of say, like, they put this into separate things, but really you should really deliver just one file. And so the fact that the optimizer ran ahead and broke up our files even more, right? What it means is now bundlers have more freedom. Instead of bundling things based on files, and files, remember, are kind of logical. So a file will contain things such as a component and a listener. Let's say it's something simple as a counter. The file will contain the component itself, the JSX, and will also contain the listener for clicking the button. And these things will always have to be together in a normal system because the bundlers don't know how to break things up. So the optimizer breaks it up and says, actually, no, there are two separate things. There is the function that represents the rendering of the component, and then there is a function that represents the what happens when you click on a particular button. And because they're broken apart, now the bundlers have a choice. They can put them back together if they want to, but maybe they can say, like, actually, during the rendering, we need the function, but we don't need the click listener. But during interaction, we need the click listener, but not for the rendering. And so we can separate them out and deliver them in kind of a more ideal way. So the thing that's important for Optimizer is to just like break things up into as many pieces as possible, because those pieces give the bundler choices in how you put it back together. Remember, putting things together is essentially easy. It's just basically fancy concatenation operation, whereas breaking things apart is kind of difficult, and bundlers don't know how to do that. And so the optimizer kind of knows how to do it because it's kind of a tricky thing to do. So going back to the production mode, we now have bundled our things together, and we have done it in a way where we can, for example, notice that, hey, when we server-side render a particular UI, we can, for example, notice, like, actually, the header and the footer have no interactions, and therefore we don't need to send them to the client. This isn't possible before you break things into pieces, because the header and footer are directly referenced by the root of the application. And so the bundler has no choice but to ship the header and footer included inside of the whole application. But when you break things into pieces, the bundler now has a choice. And if you provide sufficient information to the bundler basically can say, like, actually, I don't need the header and a footer because there's no interaction in it. And they got SSR'd on a server. And so the template, the HTML, is already present. And the only thing I really have to send across is what happens when you click on this button. And so as a result, the bundler can produce those ideal size bundles. Now, Qwik has resumability, which means that it doesn't need any of your application code to make the page interactive again. And that means that the first time you click, Qwik has a problem. And the problem is, like, well, if I do nothing special, then the first time you click, I need to get a hold of the event listener for this thing. And remember that there's a bundle which contains not just the click listener, but a bunch of other related things that I need. But I need to download that particular bundle. And so I would have to wait for that, the first time I click, I would have to wait for that bundle to download. And so we need to do something to make sure that doesn't happen. And so the thing you want to do is you want to start loading all the code as soon as possible, right? So you have your application that shows up as HTML. The application is immediately interactive, but we have a service worker that is sitting in the background, and the service worker starts loading the code that is needed for the possible interaction. What the service worker knows is that actually it is not really possible for you to do anything to the header and the footer because that's static code. There's no behavior in there. So there's no need to download that code because nothing that the user can possibly do could cause you to download the piece of code, right? So the code just never gets downloaded. Instead, the service worker knows like, actually, but I do see a button on a screen. And a button is one of the things that the user could do. So I have to make sure that I have the code associated with the button downloaded as soon as possible. I also see that there is another button below the fold, but that below the fold button, it's likely the user might scroll into a position and see it, but you can't click on it because it's below the fold. So the prefetcher or the loader, the service loader says like, okay, I'm going to download the button that's visible first. And then after I'm done with that, I'm going to download the other button. But at the same time, I know that the header and footer, I don't need to download because there's just no code path that could possibly get me there. Right. And so the service worker is kind of worried about the fact that like, hey, the network connection might disappear. It might be a slow network. So let's upfront download all this code as soon as possible for our code. And that's what it does. Now, it turns out that you might think like, well, I can just go and add a link to my bundles as a prefetching tag to the browser. Turns out that doesn't quite work the way you think it does. And we found out this hard way. Originally, when we built Qwik, we just generated a prefetching URLs for the bundles. And so what we discovered is that it worked great in Chrome, but not so much in mobile and not so much in Firefox and other browsers. And so we kind of started digging in and we realized mobile browsers ignore prefetching because their attitude is like, I'm on a mobile network, therefore I want to limit the amount of code I download. And so because prefetching is not strictly required, I'm going to ignore the prefetching, which is kind of funny if you think about it, right? Like the very act of me saying like, I'm going to need this code later, the mobile browsers don't download. For whatever reason, Firefox has a code in there that says, I will only prefetch things that are HTTP, but not HTTPS, which to me seems just backwards. Like if anything, you should download the secure one, not the non-secure one, right? Because the world has kind of moved over to secure world. Firefox just ignores anything that is secure, which is also kind of interesting. Like, okay, so you're not doing that for me either. And so we kind of started digging into this and we just kind of came to the conclusion, that's one problem. So the other problem was also that let's say the prefetching starts downloading a bundle, but then you go ahead and click on that button anyways. And so now you actually have two requests going on because the browser doesn't know if it's safe to reuse the request because the first request hasn't come back and it doesn't have the header cookies in there, header cache information. And so the browser is like, well, I don't know if it's reusable or not, cacheable, and therefore I'm going to have to make a separate request. And so you get double downloads as well. So all of these reasons, we kind of looked at the prefetching and we decided like, this isn't going to really work. And so instead we went down the route of a service worker where you have full control. And service worker gives you a lot of control. It can tell, dedupe the multiple requests. It can change the order, the priority on the fly as it's downloading and as it's seeing that you have interacted in the page in a particular way. And so the service worker's job is to just make sure that the code downloads eagerly so that it's available. Now, at this point, you might say like, well, downloading code eagerly and downloading code, the typical framework that has hydration, isn't it the same thing? Like, what's the difference between the two? And there is a big difference. So first of all, the bundles that you have to download are way, way smaller because remember, we were able to look at the components and say, these components will never, ever re-render on the client. And so just don't include them, right? So out of the box, without any other modification, you already have less code to download. So even if you ask the bundler to just create a single bundle out of all of your stuff, your bundle is already smaller because that bundler will not include a whole bunch of components that I will call essentially static components or render only once on the server components, right? That don't really re-render on the client. And it turns out there's a lot of components like that. So you have this one already. The second win you have is that you don't have to execute that bundle. Right? Normal systems have to eagerly execute the JavaScript code in order to kind of recover the information about where the listeners are, click listeners, and state, component boundaries, and all these things, right? None of that stuff needs to happen in Qwik. And so even though you're paying for the downloading of the bundle, A, the bundle is smaller, and B, you're not actually executing the bundle itself. And the last benefit that you get is that we can actually reorder the bundles on the fly. So normal system, if you build a single large bundle, the normal system has to download the single large bundle. And even if you create two smaller bundles, it doesn't really make a difference because when hydration happens, the hydration says, I need the main bundle first, and then I'm going to traverse and go to the child bundle, and then I'm going to do work over there. And so you can't change the order to it at all. With Qwik, you kind of have a slider, right? And with this slider, you can say like, I want, just a single bundle, or you can slide the slider to the other extreme and say, I just want a function per bundle. That's the other extreme, right? Neither of these extremes is a good place to be. And so instead, you need to find kind of a location where, you don't have too many bundles because that's not good either. But at the same time, you don't have too many bundles because you want to be able to kind of reorder them. And so one of the things this service worker can actually notice how the user is using the application. And based on that, can actually change the order of downloading things that you have. And I really want to stress, I think this is super important, although really hard to explain, is that to Qwik, the way you configure the bundles, not the way you decide which symbol goes where, is a configuration information, not a change to the source code. Like in normal systems, if you decided I want a second bundle here, I have to refactor my code to introduce a dynamic import. So I have to move the code to some other location. I get a dynamic import. I have to wrap that inside of a lazy. The lazy becomes a suspense. Suspense is what I put inside of the component. There's many things involved for me to do as a developer. And then if I realize that I put this lazy loaded boundary in the wrong location, there isn't a way to undo it. Like I literally have to move the code back into the correct original location. Whereas with Qwik, the choices about the bundles is not a source code developer concern. It's a configuration information. Like you configure the bundler and you say, I want more bundles. I want fewer bundles. I want to make sure that these symbols are together, or no, these symbols are not needed together. They should be separated. So there's many layers of things that we went through. And I think what part of the problem is that existing systems don't even have a vocabulary for this. Right? If you come from an existing framework and we start talking about like, we can do these bundles and we have the symbols and we can move them to separate files and we can put them together, like you're lost because you're like, what are you talking about? Like none of this stuff is things that I ever thought about in my existing framework because, there was no way to think about it. There was nothing that the framework kind of given you as a possible, knobs that you can turn in order to optimize things. And instead, the way you would optimize things is you would move source code around in your code base. Whereas here, we're saying like, no, don't move the source code around. We already done that for you, right? The $sign, everything that moves around. Instead, now we have all this kind of knobs that you can turn and you can choose different things. So again, kind of a rehash of the whole thing is, what we do is we take your source code and we shred it into as many functions as we can possibly find. To us, the more the better. In the development mode, you download these functions individually and cause, kind of a big waterfall effects. We don't think it's a problem for development, but this is what's happened. In production, what you do is you take a bundler and you say, go and reconstitute these symbols back together, these functions back together in an ideal way, in a way that kind of reflects how we think the system's actually going to be used. And then you can, decide, do you think having a one large bundle is better than 5 smaller bundles? Like, I don't know. You need to experiment and find out. But the framework allows you to do that. And then those bundles are then given to the service worker, and the service worker eagerly downloads them so that as a user, when I click on a button, I will never have to wait for the download, right? Like the click will be instantaneous.
You're listening, JavaScript Master Podcast. Listen, code, repeat. Everything you need to know to become an JavaScript super developer.
Thank you for this complete answer. In the previous episode of this podcast, we started the topic of the magic $sign. And think this is a good time to explore this idea.
Sure, let's dive into it. So I guess you can kind of back up and ask the question, like, why do we need this, right? Like, what is it that this $sign allows you to do that, other frameworks don't have it? Why do we need it? Actually, I'm going to put an asterisk on it. Actually, other frameworks are starting to have it. Turns out Solid is added a $sign to their code base, and we can kind of talk about that a little later. So back up a second, like, what is it that it provides to us, right? And the thing that the $sign provides is you can think of it as an automatic lazy dynamic import. Sorry, not automatic lazy loading, automatic dynamic import. Because a bundler can only include or not include a piece of code only if you have a dynamic import property, right? If you have a direct reference between two symbols, then the bundler has no choice but to include both of them, right? And so what you need is a way to break up the code base into lots and lots of small pieces. And this is just a feature that is just not available anywhere else. And the reason why this is not available anywhere else is because breaking things into multiple pieces implies a promise, right? So if you have, let's say you have a component A referring to component B, like let's say you have a parent and a child component, right? So they're referring to each other. In all existing systems, if you have such a relationship between parent having a reference to child, the bundler has no choice but to include both the parent and the child. And there is nothing you can do to kind of break this because there's a direct reference, right? So if you want to make sure that the parent and child are loaded independently from each other, you have to take the child and put it behind a dynamic import. Except existing systems say like, yeah, but I still need to have a reference to something. So you need to create kind of a facade of what, like, hey, this is where child would have gone, right? But it's not the actual child. It's just a facade. It's just a placeholder until you can go and download the child. And so typically the way this is done is that you take the component you want to lazy load, like a child, you move it to a separate file, you leave behind a dynamic import, but you can't just put the dynamic import inside of a template. It doesn't work. Instead, you have to somehow turn the dynamic import into this facade. And so there's usually helpful methods, like, for example, in React, there's this thing called a lazy, which creates a component that lazy loads the children. And then when the lazy loading happens, then the component becomes the other component is being lazy loaded, right? But now you have this problem that, yes, but this component may or may not be here. And because it may or may not be here, we need to have some kind of suspense boundary, right? So you have this component that may or may not be there because it's lazy loaded. And now you have to put it instead of some kind of a suspense boundary. And then the framework has to deal with the fact that as it's rendering, it may come across a child, and that child may or may not be there. And so it needs to lazy load it if it needs to. And if it does a lazy loading, then it has to re-render again because, it kind of stopped the rendering process, lazy loading happened, and then re-render rendering process again. And so all of that is a lot of work. And all of that is both mentally taxing for the developer, but also it creates kind of ugliness in your code base. Like, you don't want to mentally think about it, which is mentally you just want to think about it. I have a parent, I have a child, right? And so the thing that is hard, the thing that the other frameworks don't have, is that every time you see a $, that function, that reference, gets turned into a promise-based reference, right? Because of it. Now, you can't just go to the existing source code and put promises all over the place. The existing framework will have a fit about it. But Qwik is made in this very unique way that it can deal with this. And this is what gives the Qwik the superpower, because all of these references can become promise-based, right? And so I can actually in Qwik give you either a reference directly to a component, or I can give you a promise of that component. And Qwik, these two things are essentially identical. It says Qwik just doesn't care. It's like I can take either one, right? And because Qwik can take either one, what it is it is okay to take our source code and turn it into tons and tons of promises, right? Normal frameworks can't do that. And because they can't do it, they cannot have an automatic way of breaking things up into lazy loaded chunks, because it introduces a promise. And that promise is what kind of ruins your day in the existing frameworks, right? So step one is you need to have a framework that can deal with promises. Step two is you need to have a way to automatically extract functions so that they become promise references. And this is what the optimizer does. It takes your code base that looks all tangled up, everything referring to everything else, and therefore the bundler can't break it up. And instead, the optimizer breaks it up into pieces and says, look, now there's all these promises everywhere. And then the framework has to be smart enough to be like, it's okay. You change the meaning of the code base, but the framework says, it's okay. I know how to deal with this, right? And this is the reason why Qwik basically can do what the other frameworks cannot do, right? So Qwik has this idea of a $, that says, turn this thing into a promise. And it requires two parts, right? One part is the compiler or the optimizer or the bundler needs to know how to move the code around. And the second part is that the runtime, the framework itself, needs to know how to deal with it. And so this is the reason why basically Qwik has this new concept of this $ that don't exist anywhere else, because all the other frameworks just, they can't even talk about it, because they are insistent on this idea that they have direct references to everything, not promises, right? And so these $ are a new concept, and it really just means, give me, I don't want to have a direct reference here. I want to have a promise-based reference, and that promise-based reference underneath gets turned into a dynamic import. So that's kind of a new and unique thing in Qwik.
Sounds like a very interesting one.
Imagine you have a click listener, right? And we talked about this idea that $ turn things into promises. Okay, but they actually do something else also. What they do is they do two things. One is they can generate essentially a URL to that code base. And the reason why this is important is because URLs are strings, and therefore they're serializable, right? And so what the $ does is it not just moves the code out and leaves a dynamic import in there, which is a promise thing, but it moves it out in such a way that if you know a URL, which is really just a combination of the bundle and the exported symbol name, those two things, if you know those two things, then you know what code you're referring to, right? And this is important because what this allows you to do is put that URL into the DOM on a button. So what you can do is take the URL and put it in as an extra attribute on a button. And then when you click on the button, you can have a teeny amount of JavaScript, which we call the quick loader. That quick loader can just intercept the click event. And what it can do is it can go back to that attribute and say, hey, what code do you want me to load? And that contains two pieces of information. It contains the bundle. So it goes and fetches the bundle. And once it has the bundle, it contains the symbol name that you want, which means what is the exported name of the thing that you want. And so it can put together all these pieces. Now, obviously, as we talked earlier, there's a service load worker that makes sure that the loading is served out of the cache, so you don't have to wait for it, right? And so now you get a piece of code that can execute. And that the execution of the code is really what the Qwik listener is. However, there is one more problem to solve. And then one more problem to solve is that when you click on the button and you execute a piece of code, how is that piece of code supposed to know what is the current count? Right? And so the normal answer to that is like, well, it was a closure and therefore it closed over the state of the system. And so when you click on the button, you can just get the number. And so the URL contains not just, what bundle you need to download and also what symbol, but it also contains information about what state needs to be restored for this closure so that this closure can continue running. And when we say state, we actually know how to serialize quite a lot of things. Obviously, all the things that are obvious, that are JSON, but also signals. We also know how to serialize stores, dates, promises, all kinds of interesting things, and even functions. If you think about it, that closure became serializable. As long as I know what code to run, in other words, as long as I know which code to download and execute, and I know what state to restore for that particular function, it is possible for me to serialize closures, right? Closure is a state plus code. And so this system allows us to serialize closures. And so if you think about it, a Qwik listener on a button is really just a serialization of a closure that contains the code to execute and the state to restore so that the function can increment some counter and the right things can just happen afterwards. Right? And this is a brand new concept that just does not exist in other frameworks. And because of that, there is new syntax that you have. So that kind of explains how the Qwik listeners work. So let's jump into Qwik City, which is actions, loaders, and server $, right?
Exactly.
Which you were alluding to, and I kind of took a detour. The reason I took a detour is because I think it's important to understand that with the $, Qwik can serialize closures, like Qwik can serialize code. Qwik can give you references to things that are both code and data. So how does this kind of work out? So in Qwik City, one of the things you need to typically do is you navigate to a route, and the route has some data associated with it, and so you need to execute the data. And so because we know how to serialize closures, we have this interesting property that it is easy for us to have a piece of code that is created, like a closure that's created in one location, such as a server, and then move it to the client. But the opposite is also true. We can create a closure on the client and send it back to the server. And so that's kind of a form of a RPC. And so what that allows you to do is that when you have when you navigate to a page in Qwik City, the first thing that we execute is a loader. And a loader is just a function that fetches data from the database. And because it fetches data from the database, that function can never be sent to the client, right? Because doing so would bring all kinds of dependencies like a MongoDB driver or something like that. Clearly stuff that cannot run on the client. And so Qwik City has intelligence to kind of be like, oh, this is one of these special functions that I'm not allowed to send to the client. So instead, it creates a kind of a wrapper around it and sends the wrapper instead. It basically sends a proxy. But what it allows us to do is that you can then call that proxy at any point, and you're actually calling a function back on the server.
Now a question from a different angle. What databases do you recommend to use with Qwik?
Yeah, so the code running on a server can execute any code that you can execute in that environment. So if Qwik on a server is running in Node.js, then anything you can possibly do in Node.js, you can do inside of those Qwik functions, right? Now, obviously, if you're running in like Netlify or Vercel, that's a very different environment. And there you cannot execute certain things, right? So it all depends on the environment you're running in. Qwik has no opinion on that. Well, all that Qwik is basically allowing you to do is to make remote procedural call between client and the server in a very seamless way. So we were talking about these loaders, right? So loaders allow you to load data and then send the data to the client then renders it. And then you have the opposite problem, which is like, oh, so now the user interacts with my data somehow, and I need to tell the server back again. And so for that, we have actions. And actions are really just forms. And the reason that, because they're just forms, you get a nice benefit, which is that even if you turn off JavaScript, your application still runs. It's fully server-side rendered, and it's a typical multi-page application, round tripping that you're used to in the good old days, right? But it works. Whereas if you turn on JavaScript, we automatically intercept form submits, and by intercepting the form submits, we do many of the emulated behavior in JavaScript, which is much, much faster, but it gives you the same exact behavior. And I think that creates an interesting thing, because it means that if you stick to loaders and actions, you can have an application that has interactivity of an SPA, but has kind of the mental model of an NPA. But more importantly, even if you turn off JavaScript, the application still runs and works the way you would expect. And the reason why this is important is not because I expect anybody to turn off JavaScript. Is because it shows that if you turn off JavaScript, that is literally what the SEO sees. And so you basically have an application that is SEO friendly out of the box without even trying. And so loaders and actions are kind of the two ways in which we can build these kinds of applications that, feel very quick and fast in the way you're using them, but at the same time have a kind of mental model that is compatible with the SEO that you kind of get out of the box. So if SEO is important for you, this is kind of the way to go.
We know about how difficult it is to achieve a good SEO, especially we talk about single page application.
That's right. SEO is extremely difficult to achieve. And it just kind of comes naturally out of the box because what QWIK is trying to do is it's trying to pre-render as much of the application as possible on a server, right? So that it doesn't have to run it on the client. And by not running these bits on the client, it can delay execution, right? So a natural consequence of this is that the application just becomes extremely SEO friendly without even trying. As a matter of fact, it's just how the system works, right? There's just nothing special to do or anything like that. And again, you can see that by turning off JavaScript. Again, not that I'm suggesting that that's not how you should use the web. It's 2023, but it shows what the SEO sees. And what you're going to discover is that the SEO will see pretty much the whole thing. Now, so loaders and actions are kind of ways of getting data to the client and ways of getting data to the server in a way that is, 100% SEO compatible, and in a way that you don't even have to have JavaScript on the client to make it work. But sometimes, JavaScript is the thing we would want, right? And so one of the things we can also do with this pattern is we have a server $, right? So the $, means take the first argument, which in this case is a function, and pull it out into a URL that we can lazy load. And what the system can do is then kind of realize, actually, that function, I will make sure that it will always stay on a server, and instead on the client, I'll give you a proxy to this function. And so out of the box, you can just drop server $, you take a closure anywhere inside of your code base, whether it's a click listener or like an effect or anything of that. And you can just say, oh, I need to do a little bit of work on a server. And you just put that work inside of a closure, you wrap it around a server $, and you invoke it, and that automatically invokes on a server. So you end up in this world where this client-server separation is very fuzzy. And a lot of people, come to it and they're like, oh, that sounds like a horrible idea. Like, that's terrible. Like, why would you want to mix these things together, right? And I understand where kind of the concern is coming from. But I do want to point out that the first time most of us have seen JSX, we had a similar kind of a strong reaction of like, this seems like a bad idea. Why would you want to mix all these things together? But then in practice, you're like, I actually like it, right? So I know it sounds like a crazy idea of mixing server and client code, but actually in practice, I think it works out rather nicely. Because you have these kind of labels and you understand things like actions and loaders and server $sign run in a particular domain. Oh, by the way, you can also have a worker $sign, which now makes it that you can run this code inside of a web worker. So it turns out that these $signs, what $sign at the end of the day is a way of serializing a closure, right? What this gives you is not just the ability to move code between server and a client, but also move it to like a web worker or some other place, right? So this is a nice property to have, and it opens up a whole new ways of using it. And again, I'm going to go back saying, like, I know it's kind of hard to talk about because there is nothing equivalent in where you came from, because no equivalent systems exist for kind of extracting this code and lazy loading and creating proxies, etc. But that's the thing that the $sign gives you, is it gives you this ability to do that. And I kind of mentioned that like other frameworks such as Solid have started doing this as well. So Solid also has a server $sign. It's not as powerful as the one we have because they can only capture functions, not closures. So you can't close over variables. But nevertheless, I think this is an area where people are recognizing is like, sometimes it's just convenient to be able to execute some code on a server without going through a complicated ceremony of creating an endpoint and a URL. And, there are advantages and disadvantages to both directions, but sometimes you just want something simple, quick, and easy, right? And that's kind of what Qwik wants to deliver through these things. And whether it is running code on a server or in a separate web worker, it's all just different aspects of the same exact thing.
Miško, thank you for today's recording. And I'm already looking forward to the next.
See you soon. Later. Bye.
Bye-bye.